it myself.
Hello everyone. Hi. So I think it's time we'll start the mini lecture. So how many of you are in the civil engineering? Okay, you will see me often. Environmental engineering? Applied earth science? Nice. Welcome to Delft. Welcome to new program. I'm Dr. Ajay, lecturer in the section of Pavement engineering. Let me give a brief background about myself. I did my undergrad in India and my PhD at Singapore. After my PhD, I was working as a postdoctoral researcher for 1 year, and I've been here as a lecturer for the past 6-7 months. My teaching interest spans wide, mainly in transportation engineering and concrete structures, recently like image processing and research ethics. So, yeah, I've been working on a lot of interesting teaching related challenges. How to motivate the next generation students, how to make an interactive session, and how to create an inclusive environment in the classrooms and in the future workplaces. So, at the end of this presentation, you will be able to understand the recent advancements and future scope in pavement engineering. And you will be able to analyze critically the need for MUD in pavement engineering. Okay, as we all know, the industry is no longer about construction or the computing in older ways. We are in fact moving towards AI, machine learning, circular economy, or disruptive technologies. That's why we need to create a new master's program to integrate all these new research into the practice. So you can find me in 12 different courses, everything like trying to integrate MUD in all the 12 courses in construction materials, structural engineering, and traffic and transport engineering. Mainly to address the next generation challenges. We have already faced one big challenge, COVID-19. I think this is the first real lecture after the COVID, I guess. So we are waiting for the new challenges. Recession, climate change. We don't know what comes next. Again, you will all hear this fancy word. People will keep on talking about it for the next 2 years here at Delft, which is impact. What impact are we creating? How do we create an impact? Can we measure and quantify our impact in our career, throughout our career? Yes. Initially, we will again start from the Sustainable Development Goals proposed by the United Nations. You may know there are 17 different goals, ranging from no poverty to partnerships for the goals. My PhD work on the road accidents was just a small topic, small narrow hill in goal number 9, which is industry, innovation, and infrastructure. We shouldn't forget the bigger picture. Some goals are already well developed. Some goals are in its premature state. It needs more effort to grow. So, again, 17 goals are not the final. We can always create a new goal. So, how do we create a new goal? How do we implement the changes? How do we make the changes in the society? That's our goal. My PhD work was like I said earlier, road accidents. For every 24 seconds, someone dies in the road. People always blame the drivers or the vehicle conditions, but they always forget about one big culprit who's hiding in the plain sight, in the pavement engineers or the road engineers. We are also responsible for creating the accidents, unfortunately. So how do we reduce these accidents? Through MUD, modeling uncertainty and data science. It's a very good tool for us to reduce the accidents. Our focus is always on the road accidents and the different rainfall conditions. So one good solution what people found is the porous roads. I think you would have seen it in some videos, whenever there is a rain, water will just seep in through the road structure, and the friction will always be good throughout the rainfall conditions. Only 2 countries around the world are implementing the porous roads in a larger scale. One is Netherlands and another one is Singapore. So what my PhD was we were trying to model the porous roads through image processing and computational fluid dynamics. Once we model the fluid flow in porous roads, we can combine this with the accident capacity, accident modeling. Once we do this, we will be able to say like, okay, this particular vehicle conditions, this speed for this rainfall intensity, accidents will surely happen. In that way, we can predict the accidents and reduce the accidents. There are many applications for modeling in pavement engineering. People were investigating for the aircraft loading on the road, on the runways. Loading is extremely high in the aircrafts. As we all know, like, so how does this affect the road structure? How long is the design life for the runways? And how do we quantify those issues? With the modeling and uncertainty, we can do all these difficult jobs, which we cannot do it numerically. So, but it has its own flaws. It has a lot of flaws at this point of time, which we need to be able to identify those flaws and rectify it. One flaw is the image processing. It has a step called image segmentation. We have to convert the images into black and white, and while converting, there are many assumptions, which people have been ignoring for the past 15-20 years. Because of this, again, accidents were happening. It may look as simple, but the effect is very high. So once we have all the images, this is an X-ray image, very similar to the medical X-ray scanning. We did the X-ray scanning for road samples, and this is a 3-dimensional image. So once we have that image, we can divide it into multiple zones. Zone A is the cement and aggregate phase. Zone B is the interconnected voids, and the last one is the isolated voids. Our focus is the interconnected voids, if you are looking at the porous roads. If the interconnected voids is higher, if we design the interconnected voids, we can increase the water flow and reduce the accidents. So this is what people have been ignoring for the past 15 years. The first image is the raw image from the X-ray scanning. When we are dividing it into, when we are proceeding it for the thresholding or the segmentation, we have multiple algorithms. Each algorithm has its own advantage and the limitations. So this is what my PhD is about, like using each algorithm, feeding it into the computational fluid dynamics, and trying to find out what's the error percentage. When we did this, we found that the error can be as significant as 136%. So we proposed a small algorithm, which was producing it less than 2.5%. People were accepting this new algorithm, and our focus is again on accidents. How do we combine it to the accidents? Again, we created the road accident model, and in this we were able to find out what's the error percentage for each algorithm. So forget about the first row. The error can be up to like minus 35%. So what does this mean? If you lay a road structure which has like, if you say like there are no accidents, but in reality there will be some accidents, it's because of our fault. So we have to be very careful in choosing each and every step in the modeling, and trying to find out there are some hidden assumptions as well. So we have to be careful of all those assumptions. Yes, once we are able to solve all the assumptions, remove all the hypotheses, we can get some good quality results which we cannot get it from the experiments. Imagine, look at this figure, like x-axis is the vehicle speed, y-axis is the friction. This one we obtained it from the simulation models, and the line 45 is the limit, like interface we call it. Like area above this line is considered as safe. Area below this line is considered as unsafe. So we can artificially simulate different rainfall intensities, and we can artificially let the vehicle run on the road structure. In that way, we will be able to predict at what's the friction value at each speed and rainfall. We did the same for different road samples, and we found that some samples fails terribly. Like if you look at the P2, we shouldn't even think about P2. It's complete disaster. if you look at sample P3, it will behave well until 100 mm per hour rainfall intensity. If the rainfall is much higher, accidents are going to happen for sure. In that way, we can go forward with a new concept called variable speed limits. Based on different rainfall intensities, we can change the speed limits. Yes, I think that's all about the modeling. I'll go forward with the uncertainty. There is uncertainty in everything, like compared in pavement engineering, in jobs, everything from all the aspects. So how do we combine this with the data science? Yes, with respect to pavement engineering. If you look at any road structure, it may look like a homogeneous structure, but it is not. Each and every point is different. If you take a core from each and every point, its structure is different, internal structure is different. So how does this internal structure, small variation in this internal structure, affects the fatigue life? No one knows. We have to do some kind of research. It says like even for a normal roads, the coefficient of variation or the percentage difference can go up to like 20 or 30%. But no one studies that fact at this point of time. Again, our focus is always friction and accidents. That's why I have one PhD student who's working on area like combining autonomous vehicles with the scanners, convolution neural network to predict the accidents. So when we have an autonomous vehicle, if you combine it with some sensors, it will scan the road surface when you drive. And when you're driving, you can again find the dangerous points, like which point there will be some accidents. In such a way, you can create the accident-free environment. So for this, we need data. We need like lots of scanned data, which people are doing it. We need like more than 1,000 data points. Once you have the scanned data and like accident risk, you can train the convolution neural networks. Once you train it, you can just implement it like in the faster way. So the research philosophy is again like you should always try to combine the impact on science versus impact on practice. If the science is not fancy enough, people will not do the job. People will go for different disciplines. So that's why we always try to have the more fancy work, but the professors are mainly interested in the practice. If the research is not practical enough, we will not get the funding. So we have to bridge this particular gap. That's why like we will initially start from more fancy work, which will have less field application. But slowly we will go forward with the more practice. We need to make everything as simple and as applicable as possible. We also need to think about the failures. There will be a lot of failures as well. We are still in the failure zone for the new program, like with respect to a lot of modeling uncertainties. Our job is to make it work and make it as practical as possible. Yeah, let me give a brief background about what we are currently doing here at TU Delft in the section of pavement engineering. One project is, this is a PhD student here. He is trying to understand the properties of bitumen. I think you all know what is a bitumen binder. So how do we predict the behavior of bitumen at different loading conditions and at different temperatures? We have a lot of data already. We are using the ANN to feed the data and train the data. And if you're not able to find some data points, you can always rely on simulations. Through the simulations, you can find the data points and feed it back to the ANN or CNN and predict its lifetime. The second project which we are working on is the moisture damage. How water interacts with the bitumen at the micro scale or nano scale or the molecular scale. So the person is working on the molecular scale, like what's the reaction between each elements and how can we predict the failure. I don't want to bore with a lot of figures. I'm just throwing all the figures at this point of time just to show that we are working on something regarding this. So don't worry about all these equations. I'll go to the third project which we are working on. Yeah, the third project is again like predicting the behavior of asphalt. This is just with the ANN and just with ANN. We have like 30 years of data. People are training the data to predict its at what temperature we should lay the road. In the field, the temperature conditions are not unique. Like every location is different. How do we lay the perfect road such that the life can be extended? Even a small mistake in the field can lead to a disaster. Like it can be like the lifetime can be reduced by 1-2 years. Again, everything is connected back to money. It's again like a loss in the budget. Yes, the final project which we are working on is the circular economy or the sustainability part. Once we reach the end life of the road structure, how do we reuse those materials? Are we reusing those materials? No one knows. We should start reusing it. We need some data. So that's why people are collecting data for this particular project. I asked the postdoc to do this. I think it's yeah. At the end, we should always connect it back to the sustainable development goals. Whatever research we are doing, it's again a small narrow hill. We shouldn't forget the bigger picture. And we should quantify our impact. Is it possible to quantify our impact? Through some means, like I try to reduce the cost by 2% or 3%. Something we should try to come up numerically. And we should always address the bigger questions. Why do we need to create an impact? What if we don't address these problems? What will happen? And how do we convert our knowledge into wealth? We need to figure it out. Yes, I have a small YouTube channel. If you are interested in my teaching or research, you can have a look at this. Yeah, I'll end the presentation by sharing a short story from Pirates of the Caribbean. Do you think Captain Jack Sparrow plans everything out, or he just shifts the plan according to the weather conditions or based on wind? Well, the answer is like both. He plans something and the environment will take care of something for him. In a similar way, we will plan something for you. You should also start planning something for your future. Thank you. And if you could provide some feedback for today's session, it will be very helpful. And if you have any questions, please feel free to ask me or drop by my office.